Okay. Hello, people. Welcome to Letstute. If you haven't subscribed to our channel, then do subscribe and don't forget to press the bell icon to never miss an update from us. I want to welcome all of you who are present today for this live lecture. My name is Sanjana Das, and I'm a physics teacher. And today we're going to cover a very important topic to be more precise. Today we are going to cover a very important topic, and the name of the topic is motion. Now, motion is a topic which comes in all of the curriculum. There are particular topics that is being covered. For example, what is speed, what is velocity, what is distance, what is displacement, what is acceleration. So all of these things we are going to cover. Hi Sheetal, how are you? How is everyone? Whoever is there, by the way, I'm going to tell you, I'm going to have a doubt lecture today. So in this, hi Hemant, hi Deepak, how are you? It's so good to have all of y'all back. Okay, so in motion, last lectures, if you all were there in the last lecture, we were doing numerics. Now the problem is that some people did say that they just didn't want numerics, they wanted some part of concepts. So the thing is, I thought, why not take some concepts and just club all of them together rather than taking other different lectures. So today's lecture would be clubbing the concept is what is motion, what is rest, what is distance, what is displacement, what is speed, what is velocity, and what is acceleration. Seven concepts. We are going to take seven concepts and club all of it together. Yeah, Deepak, I am fine. It feels good to have old people. It feels so good to see that all of y'all are there. By the way, before starting the lecture, hi Usha, good evening. Guys, before starting the lecture, I know a lot of y'all have subscribed, and the people who have not subscribed to our channel, please do it. And also, we have a lot of courses in science. So just go and visit www.letstute.com and see how good our courses are. Now let's come back to what we were coming here to do today, and that is to discuss some of our courses. To discuss some of our concepts. Now, some of the concepts may the topic that we are going to cover is motion. Now, in motion, first of all, the question comes: what do you mean by motion? Tell me, what does motion mean to you? You all can just put it in the chat box. What do you mean by motion? I'm going to teach you what is motion, but let's see what you know about it. What is motion? What is rest? What do you mean by the word stationary? What does all of these things mean? Just put it in the chat box, whatever you know, because I'm going to teach you, but I just want to know how much y'all know about it. Okay? Fine. So we are supposed to talk about motion. We are supposed to know what do you mean by motion. What is motion? What do you mean by motion? Come on, guys. I want it in the chat box. Come on, people. What do you mean by motion? I gave you a hint, something which moves with time. But what do you mean by movement? Movement matlab what? What do you mean by movement? What is it that is actually moving? So let me make it clear for you. If you look at the car, okay, if you look at the car, initially the car was not moving. But then, if you notice, the car is changing its position with respect to the surrounding. And because the car is changing its position with respect to the surrounding, if it changes continuously, very good, Hemant, proud of you. Deepak said motion means pull or push. No, Deepak, it doesn't mean pull or push. Push or pull is actually force, Deepak. Yes, Usha, motion is a moving body. Proud of you. Hemant, you've given the exact definition that I was looking for. Guys, Hemant's definition, a body is said to be in motion if its position changes continuously with respect to the surrounding or to the observer with the passage of time. Actually, it means, let me just not confuse all of you with that. No, Deepak, it's fine. Let me just not confuse you with all of those words. I would just say that motion, guys, motion is something which moves with time. And what do you mean by moves? Moves means something which changes its position. And I'm here. If I'm changing my position with respect to the surrounding, then I'll say, if I'm changing my position with respect to the surrounding, I will say that I am in motion. So if I'm moving with time, if I move with time, then I say that I am in motion. But if I'm not moving, yeah, so what Usha said, you're actually correct. Moving is motion. But what happens if something is not moving? Not moving means, hey, according to Heyman's definition, if something is not changing its position, this I have just kept my hand here and my hand is not changing the position. It is not changing the position with respect to the surrounding. What do you say to that? Come on, guys. I want the answer in the chat box. What do you say for a body which is not changing its position with respect to the surrounding? What do you tell to that body? Come on, guys. I want the answers in the comment box. Just tell me, what do you mean when a body, very good Hemant, very good Deepak, proud of you. You all are correct. Yes, guys, all of you are correct. Yes, Ankit, you're absolutely correct. Oh, Deepak, you actually got the correct word. Both of the words, rest and stationary, are right, guys. Both of it is right. If a body is not changing its position with respect to the surrounding, the body is said to be at rest. Or the technical word that we use is stationary. The word stationary also means the same, that the body is at rest. Remember, now this is some grammar terms that we are using. If you don't use it, there are chances your teachers may cut marks, because I've seen teachers take away marks. First is, a body is in motion. Guys, remember, a body is in motion. A body is at rest. These two are different. Just don't write a body is in rest or a body is at motion. That's wrong. I have seen teachers take away marks where people have written a body is at motion. No, a body is in motion and a body is at rest. At rest means the body is stationary. Okay, stationary means the body is not changing its position with respect to the surrounding. Now, this was done. Now, the question comes, stationary. So, we just knew that stationary means something which does not change its position. For example, if you're sitting, you are not changing your position with respect to the surrounding. But I have a question. I just told you motion is change in position with respect to the surrounding. Stationary means the body is not moving or a body is not changing its position with respect to the surrounding. But is it really stationary? I'm going to come to an important concept, a very, very important concept. An object is said to be stationary if it is not changing its position with respect to its surrounding. Very good. Very good, Hemant. Proud of you. But now here's the question. Now, this is a technical question and this is a very thoughtful question. This is something which actually Einstein had a thought about. This is something which Einstein was thinking. He thought, is motion or is the body really stationary? If I'm sitting over here, am I really stationary? Really, think about it. Because it comes to our next concept, that is motion is relative. So if you're noticing, see, normally if you take a body, it is at rest. If you're looking at a man who's sitting in a bench, he's at rest. But that man is on earth. Okay? And if that man is on earth, think about it. If there is a astronaut who's observing that man from space, see, for a normal person, yes. So for a normal person, we all revolving around earth. Yes. You're true. The earth is revolving around sun, and the earth is also rotating around itself. So if the earth is rotating, it is revolving around. I can genuinely say that the earth is rotating, or in general, I can say that the earth is in motion. So if the man is sitting, yes. So if the man is sitting on the earth, think about it. If the man is sitting on the earth and there is an astronaut who observes that man, think about it, what will happen? Will the man appear to be at rest or in motion? Let me say, guys, you know that the earth rotates and revolves, okay, and the man is on earth. There is an astronaut who observes this man from space. So from space, if he is observing this man, tell me, will the man or will the person who's sitting, he will be in motion or at rest? Think about it, guys. Yes, ma'am, it is relative. It can be said that by observer. Yes, Deepak, very good. Very good. He's in no actual motion or rest. Yes, Hemant, a technical term. Actually, the technical term is that motion is relative because it's the perspective of the observer or the initial frame of reference of the observer that's important. Let me tell you what's inertial frame of reference or what is perspective. It is where I am standing. When you go to your higher grades, you learn a little more about it. But it is more of like if where am I with respect to the surrounding? If with respect to my surrounding, let's say if I'm in a train or let's take a car. So if you are inside a car, you are driving a car and your friend is with you. So your frame of reference is that car. So because your frame of reference is that car, and if you look at your friend is stationary. So you will say that, okay, your friend is stationary. Yes, very good. Very good, Usha. So your friend is stationary. Why? Why is your friend stationary? Because your frame of reference is that much. But let me just twist it a little. What happens if you're observing a person who's sitting outside? Think about it. Whenever you are in a car and you see a person who's sitting outside, you feel that person is moving. Once again, when there is a person sitting outside, I'm going to play this again. You are inside the car, for you, your friend is at rest. Okay, but when you're driving, you see a person moving backward. So this means that for you, that person is moving. For you, that person is moving. But for someone else, the person is at rest. All of these give yes, very good, guys. Very good, Usha. Okay, yeah, Usha has given that answer. By the way, whatever you're saying is actually true. Deepak gave a line, motion is relative. Hemant gave no actual, there is no actual motion and rest. You are absolutely correct. It's given in the screen, motion is relative. It means it depends on the position of the observer. So if the observer himself is in another frame of reference, okay, and this frame of reference is in motion with the other frame of reference, there are chances that you will feel, okay, that body is moving. That body is moving. But then, remember, someone else, someone from that frame of reference, for that person, the body is not moving. So all of these terms into one thing, that is motion is relative. What do you mean by the word relative? Now I'm going to crack a PJ here to make you understand it. If you don't like it, tell me in the chat box. The word relative means, for example, my mom. She's mom to me. She is a wife of my dad. Okay, she's daughter-in-law of my grandmother. So remember, there is one person, but depending on us, the relations are changing. She's a relative, as in depending on us, it's different. She is different, but her relations different for different people. That is, it is for different people, or it depends on who I am. If I am going, I'm gonna call her mom. But if it is my grandmother, she's going to call her daughter-in-law. That is, it is different for different people. Hi, Shivani. How are you? Shivani, we are trying to do a chapter named as motion. In that, we are doing motion. We've done with motion. We are done with rest or stationary. Now, we are doing a tricky concept, and that is motion is relative. Yes. Yeah, thank you. I thought people are going to tell me that it's a PJ. I'm extremely sorry. That just came up and I was like, let's give it to all my students. So don't write this in your exam. If you have an exam, don't give this definition. Yes. Don't give this example. I'll tell you what example to give. Give them an example of you sitting in a train. So you sitting in a train, for you, the person who's sitting in front of you, he's at rest. But when you look at the trees outside, okay, when you're looking at the trees outside, the trees are moving. Why are the trees moving? Because your train is moving actually. So, but for your, but you will think that the tree is moving. Why? Because it is observer dependent. So, by the way, I'm gonna finish the topic. Motion is relative because I've spoken a lot about it. Okay, but just remember, for the person sitting inside the car, this person was in motion. But for this person, that car and the people sitting inside it is in motion. So motion is observer dependent and not all motion are same. Now we are going to come up with some different types of motion. If you all know any type of motion, guys, yes. Guys, if you all know any different type of motion, please do write it in the chat box. Now we are coming to the different types of motion in our daily lives. Let's see if you know them or no. Just remember, just remember that motion just remember that motion is different for different ways. So now let's come, guys, come on, you all can tell me what are the different types of motion. You all can tell me what are the different types of motion, and I'm also going to tell you. So come on, think about it. What are the different types of motion? I'll give you one example. I'll give you one example. One is when a body is moving in a straight line. When a body is moving in a straight line, that type of motion is called as rectilinear motion. Okay, so Hemant has said linear motion, rotational motion, oscillatory motion. Deepak has said oscillatory and rotational. By the way, Hemant, linear motion can also be termed as rectilinear motion. Linear motion, that is when a body is moving in a straight line. Rectilinear is sort of like that. So y'all can write that out of the different types of motion, you either write linear or rectilinear, it's fine. But then rectilinear motion is a more technical term. So your teachers are going to consider that. So when a body is moving in a straight line, when a body is moving in a straight line, then you say that the motion is a rectilinear motion. Let me just break it out for you. Then you will understand it. If you're taking recti, the word recti means straight, and the word linear, I think you know, linear means line. So therefore, when a body moves in a straight line, you call it as rectilinear motion. So that's one type of motion. Come on, let's see if you have something different. One type of motion is rectilinear motion. Rectilinear motion has a lot of different examples, by the way. One out of that is the rays of the sun. Have you heard that light travels in a straight line? A lot of your teachers must have told you. Light travels in a straight line, right? Light travels in a straight line because it has rectilinear propagation. What do you mean by rectilinear propagation? That is traveling in a straight line. So one is light of the bulb, one is light from the space. Guys, even light from the space is moving in a straight line. So if someone tells you to give example, either say me moving in a straight line, or any train moving in a straight rail line, or a car driving straight, or just give them an example of light moving straight. Anything will do. Write down the first type of motion, that is rectilinear motion. Now let's come to the second type of motion. Yes, very good. Guys, let's come to the second type of motion. Now for the second type of motion, I'm so happy that you all know these concepts. For the second type of motion, let's say if you have a body or if you have a ball, you must have done this. Volleyball and all, mein, whatever, whenever you're pushing a ball or whenever you're throwing a ball, rather than making it straight, you never throw it straight. What you do is you throw it in a curve. So when you're throwing it in a curve, what do you think this type of motion is? Think about it, guys. When you're throwing an object in a curve, what kind of motion is that? Come on, think about it. If you're taking a body and throwing it in a form of a curve, what kind of motion is it? Remember, if a body travels in a straight line, you call it as rectilinear motion. But if a body travels in a curve, If a body is traveling in a curve, what do you call it? Come on, I want answers from y'all. What happens if a body is traveling in a curve? Okay, okay, I am getting answers. A circular motion? No, Hemant. I'm not saying in a full circle. I'm just saying a curved motion. Yes, you are right, Deepak, but not completely right. Hemant, circular motion is when it is going in a proper circle. But I'm not saying it takes the whole circle. I'm just saying it moves in a curve. And because it moves in a curve, it's called as curvilinear motion. We will come to circular motion. We will do that. But remember carefully, I am not saying the body goes, comes back. I'm just saying the body moves in a curve. Okay, it also has one more name. Sometimes it's if you're throwing a body and it takes a curve, it's called as a projectile motion. Actually, you must have seen those whenever you are cycling. Whenever you all are cycling, you all must have taken a curve, or you all must have taken a turn. So, or whether you must, I don't think so, you all must have drive. But if you're in a car, if someone is taking a turn, even that is curvilinear motion. Anything which takes a curve, that is called as curvilinear motion. Yes. Hi, Sivani. Hi. Hi. Yeah, I wanted the answer. Okay, curved motion, circular motion. Yeah, Usha gave the answer. It is curvilinear motion. Now, guys. Now, guys. One more thing. Whenever you are trying to throw a ball, this is not circular motion. If you look carefully, this is not circular motion because the body is not going in a circle. The body is going in a curve. For example, you putting a ball in the basket. That is also curvilinear motion. Now, just now we did two types of motion. If a body is moving in a straight line, you call it as rectilinear motion, and if a body is moving in a curve, you call it as curvilinear motion. We are going to take more examples of curvilinear motion, but then for that, it's better that you all go through our website and see. We have much more examples and concepts based on these. But I'm going to take one step forward and explain you another type of motion. Now, for this another type of motion, remember, if a body is traveling in a straight line, it does not always have to be moving together. Maybe the first body is moving faster. Maybe the second body is moving very slow. So they are not moving at the same time. And if two of them are not moving in a straight line, in a same time, then you don't call it an example of curvilinear motion. Yeah, I can give you an example of curvilinear motion. Curvilinear motion is when you're taking a turn in a cycle, when you're putting a ball on the basket, or let's say when a bowler bowls. So I don't know the correct way of doing it, but I have seen people just throwing it. So when they are throwing it, what they're doing is they are making it go in a curve. All of those, Sivani, are examples of curvilinear motion. But now I'm gonna complicate it a little and say what happens if a body travels the same distance in same amount of time. Once again, if a body travels the same distance in same amount of time, that type of motion. Now this is tricky. Do you know what it's called as? Think about it. This is slightly tricky. What happens when a body is covering? Okay, if a body travels same distance in same amount of time, it has a name. If this is one big body and there are different particles in that body, and all the particles in that body are traveling same distance, Deepak, uniform is correct. Uniform is correct. But I am saying that it is one body. One body and all the particles are moving are moving at the same time. Uniform is fine, but this type of motion where all the particles are moving together, it's called as translatory motion. They are covering the same distance in the same time. Even if they are changing the distance, all of them are together. So if I have a body, all the particles are moving together with the same speed. So that same speed, or they are covering the same distance. So that type of motion where all the particles of the body are moving with the same thing or the same speed, then that type of motion is called as translatory motion. Just now we did three types of motion, guys. We did rectilinear motion, we did curvilinear motion, we just did translatory motion. Now let's complicate it a little more. The one which Hemant told me, the one which Hemant suggested, the one which Deepak and all of you all said, that is circular motion. When do you say a body is in circular motion? So, or rotational motion. Remember, if it goes and comes back to the same position, if one particle is doing it. Remember, I have taken a tire, and in the tire, it is not moving in a circle. Rather, one point is fixed, and it is moving through that fixed axis. That type of motion is called as rotational motion. See, there's a fixed axis, and it is moving in that fixed axis only. So that type of motion is rotational motion. Very good, Usha. Remember, guys, y'all were telling me circular motion. Circular motion, mein there are types. If the whole if the whole tire is rotating in a circle, then you will call it as circular motion. But if the tire, guys, if the tire is pivoted at the center, okay, if the tire is pivoted at the center or fixed at the center, and the tire ka particles are just moving, the whole tire is not moving, only the particles are moving, then that type of motion is called as rotatory motion or rotational motion. Circular motion, remember, when will you call it as circular motion? If the whole tire is moving in a circle. But then if you are pivoting it to a point and the tire then moves, then that type of motion is called as rotational motion. Just know the difference between circular motion and rotational motion. Circular motion, the whole body moves in a circle. But in this, uh, it moves around a fixed axis. This is the fixed axis, it's moving around a fixed axis. So this is called as rotational motion, and circular motion is when the whole body turns. Okay? Any doubt, guys? Okay, very good, Sivani. Okay, yeah, Usha's given the answer for the first one. Okay, she's correct. Now let's go one step further. Now, circular motion ka some of the examples. One is the merry-go-round. Is there any more example of circular motion? You all can just put it in the chat box. One example which I knew was moving in a merry-go-round or a top spinning. So a top spinning depends. If it is at a fixed point, then it's called as rotational motion. But if the whole top is spinning, you must have seen the top spinning, then it's called as circular motion. Okay. Do you have any more examples, guys? Guys, any more examples of circular motion? Come on, think of it. Think of it. Is there any more example of circular motion? By the time you're giving me example, let me explain you one more type of motion which Deepak and Hemant were giving me, and that was oscillatory motion. See, oscillatory motion is very simple. It's a to and fro motion. Once again, oscillatory motion is a to and fro motion. If the motion is repeating itself, then it's called as oscillatory motion. Now, in oscillatory motion, a pendulum, if it goes and comes back to the same position, we say that it is having an oscillatory motion. But if this oscillatory motion or if this to and fro motion is very fast, okay, giant wheel, very good. Sivani, okay, Sivani said circular motion, fine. Periodic motion, we are coming to it, Hemant. You can say the motion of a clock is a periodic motion. But what I'm trying to explain you is what is oscillatory motion. So oscillatory motion is if there's a to and fro motion. Can anyone tell me fast oscillations? Fast oscillations, no Dhruvian, this is not grade 11, but this is a topic which can be useful for grade 11. I'm trying to cover the topic motion. I'm trying to cover the topic motion, the cycle, when we use cycle in the motion. Yes, very good, Usha. Proud of you. Good example. Good example, Usha. Yes. The motion of a cycle can also be said to be circular motion. Now, we are talking about oscillatory motion. Oscillatory motion is a to and fro motion. So if I go and come back to the same position, I am in oscillatory motion. But if I'm doing it very fast, if this oscillatory motion is very fast, then it's not called as oscillatory motion. It's called as vibrational motion. The very fast oscillations are actually called as vibrational motion. If you want to experience, hi Sadia, how are you? Sadia, we are doing a topic called as motion. We are doing a topic called as motion, and we are trying to learn the different types of motion. Now, for vibrational motion, I said vibrational motion is very fast oscillations. So to remember, yes, guitar strings. I'll give you one more example of vibrational motion. Just take your hand, put it on your throat, and try talking. Say, hi, welcome to Letstute. Hello, guys, welcome to Letstute. Hello, Sadia, welcome to Letstute. Yes, when you're using the guitar string, but that's not the only example. Even if you put your hand on your throat, you will feel a vibrational motion. The reason you feel a vibrational motion is because there is an epiglottis in your throat. And the function of the epiglottis is to vibrate very fast to produce sound. Very good, Deepak. Proud of you. Rubber band. Yes, that's an example. Rubber band is also an example of vibratory motion. Anything else, guys? Any more examples of vibration? Okay, Robin, what is there any other example of vibrational motion? Think about it. Otherwise, I'm going to go forward and start with something else. But are there any more examples of vibrational motion? Remember, very fast oscillations are called as vibrational motion. You put your hand there, you will feel that vibration. Okay, fine. Next is periodic motion, the one which Hemant was telling me about. Hemant, you are right. Remember, if the to and fro motion or if the body covers equal distance in equal interval of time, okay, if the body is covering equal distance in equal interval of time and it is repeating it continuously, if it is repeating that motion continuously, then it's called as a periodic motion. For example, the motion of the hands of the clock around it, it is a periodic motion. The motion of the earth around the sun, the motion of earth around itself, all of it is periodic motion because it keeps happening after a particular instance of time. That is called as periodic motion. So after periodic, see, motion of the earth around the sun. Also, I'll tell you what is uniform motion. You can call it as uniform motion, but the motion of the hands of the clock. But there's one more, like a straightaway definition. If a body is covering equal distance in equal interval of time, if I'm trying to cover equal distance in equal interval of time, I'll say that I am in uniform motion. These were the different types of motion that we covered. Okay, these were the different types of motion that we covered. If you want, you can take a screenshot. Pendulum's hand, yes, very good, Rabin. Pendulum's hand is also an example of oscillatory motion. Very good, guys. It feels so good when you all are responding. But now that's not the end. Now, before ending, because next lecture I'm going to do some graphical things, I just want to make you know what are some of the topics that you should know. First of all, you should know what are physical quantities. Physical quantities are quantities that can be measured. Anything that can be measured is called as a physical quantity. For example, if time can be measured, time is called as a physical quantity. If I tell you I ran 100 meter. So if I'm running 100 meter, what is it? I'm measuring distance. So if distance can be measured, that is called as a physical quantity. If I tell you, give me 1 kg of rice, what is that 1 kg? 1 kg is your measure in rice. So mass is also a physical quantity. That is, anything that can be measured is called as a physical quantity. But physical quantities, remember guys, are divided into two types. Non-uniform motion. Good, Deepak. Very good, you told me. Non-uniform motion is simply when a body does not cover equal distance in equal interval of time. I was supposed to cover it in the speed section, but I'll tell you, if a body is not covering equal distance in equal interval of time. Best example is traffic. You are stuck in a traffic, it never will you cover equal distance in equal interval of time. First, let's say it is a red light. Red light, so maybe you are not covering any distance only. Then it is a yellow light. So okay, you're getting the car started. Then it is green light. Acha, you're moving. Thoda sa you move. After 1 minute, after 2 minutes, you once again see another signal. That is, guys, remember, in a traffic or just flapping of wing, when birds are flapping their wings, even that is non-uniform motion. Okay, so Deepak, you gave me units, kilometer, centimeter, gram, meter. Yes, all of them are units of distance. Now, what are scalar quantities and what are vector quantities? Scalar quantities are quantities which do not need a direction. Best example is mass. Mass doesn't need any direction, or time doesn't need any direction. They just need magnitude. I can just tell you today, okay, what is the mass? I will tell you it is 5 kg. So you will say, okay, but what about from east? What about from west? What about from north or south? Doesn't matter. The mass will remain 5 kg. It does not depend on the direction. But in that case, in another case, let's say if you have force. Now for force, I have this one example. Okay, 200 ml of water. Yeah, that's also you can measure it. But I have a question. What are vector quantities? Now this is something which I have a lot of okay, value but no direction. Very good. But then what are vector quantities? I get a lot of different definitions for vector quantities, but do you really know what is vector? I can show you a simple example. Vector quantities, displacement and velocity. Yes, you're right. Yes, you're right. They have value and direction. But how do you prove that? So if you have a body, if you want to prove if you want to pick up that body, you are applying a lot of force. You apply a lot of force, but the body is not picking. You are not able to pick up the body because you are not applying force in the correct direction. The moment I apply force in the correct direction, I am able to pick up the body. So remember, just applying force did not do anything. I had to apply force in the correct direction. That's the reason doors may you have a push and pull. If it is written, it is push, and if you're pulling, the door will not open. But if you're pushing it, then the door will open. Why? Because force, a push or pull, that is a force, is a vector quantity. Yes, very good, Deepak. It is true. Value means magnitude. Yes, I know that. And I'm so happy all of you are replying. Once again, don't forget to subscribe to our channel. But also remember, guys, that there are some courses, there are actually a lot of courses in www.letstute.com. So just go through it once and press the bell icon. I'm repeating it a lot of times, but I'm just reminding it for all the new people here. Just don't forget to press the bell icon. Now, a quick explanation of what is distance and displacement. Now, for you to understand what is distance and displacement, let's say if there's a body, I have already explained it to you. So I'm just going to give you a quick example. If there's a body and it is moving in a particular direction, it is changing its direction, and this is its final position. So distance is the length of the actual path covered by an object. Okay, the actual path covered by an object, that's called as distance. And displacement is the shortest path. So if I'm just taking the straight line, if I'm taking a straight line between the initial point and the final point, then I'll say it is displacement. So remember, distance is the length of the actual path covered by an object. Okay, yes. Distance is the length of the actual path covered by an object, and displacement is the shortest distance between initial and final point. Don't mess it up. Remember, distance and displacement both have the same unit, and their unit, as Deepak had said, centimeter, meter, kilometer. These all are units of distance and displacement. But there's one thing: the SI unit. The SI unit of distance is meter. Don't mess it up because in your exam they will expect you to write all the answers in meter. So the length of the actual path covered by an object is distance, and the shortest distance between the initial and final point is called as displacement. Next is speed and velocity. See, if someone tells you what is speed, speed is just how fast speed is just how fast a body can move, or how fast a body can change its distance. If a body can change its distance very fast, then I'll say, okay, the body has a higher speed. But if a body is moving or changing its distance very less, then I'll say it has less speed. I'll give you an example. 100-meter race. I am I am running that 100-meter race. It took me let's say 1 minute to go through the whole thing. It took me 1 minute to run the 100 meter, but it took Usain Bolt just 9.58 seconds. It took Usain Bolt just 9.58 seconds to cover that same distance. So distance, if you have a particular distance and if you are covering it faster, this means you have more speed. Hi Supriya, how are you? Supriya, we are doing a topic named motion, and we are doing concepts on motion. We are done with motion, rest, distance, displacement, and last thing that we are doing is speed and velocity and acceleration. So speed is just how fast a body is changing. That is distance traveled per unit time. But if you're taking it in a particular direction, if the direction also comes into the picture, then you say that it is velocity. That is displacement traveled per unit time. So if I'm just taking the distance traveled, then it will be speed. But if I'm taking the direction in consideration, then it will be velocity. One more thing, both of their unit is same, that is meter per second. Always remember the SI unit of speed and velocity is meter per second. Does anyone here know what's the commercial unit of speed? Speed means how fast any body can move. Very good. Okay. Uh, okay, so I have a question. Velocity, you all understood. Deepak, is there any other unit? Is there any other unit? What do you know? Is there any other unit of speed? What's the commercial unit of speed? Think about it and just write it in the chat box. By the time you're doing that, I'll just explain you what is acceleration. Acceleration, whenever you say, okay, guys, before knowing acceleration, what's the commercial unit of speed? Do you know it? The SI unit of speed is meter per second. What's the commercial unit of speed? Think about it, guys. What's the commercial unit of speed? Well, the commercial unit of speed is kilometer per hour, AMPH. And finally, the last topic of the day, acceleration. Acceleration is, whenever you are saying the word acceleration, you mean accelerator. Accelerator is used to change the velocity or to increase the velocity. So whenever you're pushing the acceleration, the velocity increases or the velocity changes. That is acceleration, the rate of change of velocity. When a body changes its velocity with respect to time, we say that the body is accelerating. For example, if you take any body or something and when you're throwing it, its velocity increases. Why? Because of gravity, because of acceleration due to gravity. So remember, acceleration, very good, Raveen, very good, Deepak. Uh, Yes, yes, guys, you all are correct. You all are correct. Miles per second, I don't think so. But then we are using kmph, not meter per hour, guys. It's not miles per hour. Like in some countries, it is miles per hour. But in India, we are taking it as kmph, that is kilometer per hour. If you look into the speedometer, they are telling you according to the this kilometer per hour. Remember, acceleration is the change of velocity. That is, acceleration is final velocity minus initial velocity upon time. We've already done these numericals in our previous lectures, but still I'm telling you, remember this formula. This is very, very important. It can come in your numerics, which I've already taught y'all. If y'all want, y'all can just go through, but just remember this formula. Also remember, if the velocity, we say acceleration is change velocity. If the velocity is increasing, it's called as positive acceleration. If the velocity is decreasing, it's called as negative acceleration. But if the velocity is not changing, there is no acceleration only. So it's zero acceleration. One more thing, your teachers will tell you to write down what is negative acceleration, what is another name. Remember, the another name for negative acceleration is retardation. I am ending the lecture, guys. I am almost done with my concept. Do you all have any doubt? I'll just tell you what I taught. I'll just tell you what I taught. I taught you all what is motion. I taught you all what do you mean by rest. I taught you what is that motion is relative. After that, we did distance, displacement. Okay. After that, we did distance, displacement, speed, velocity, and finally acceleration. We also did the different types of motion. So, do you have any doubt, guys? Or I am gonna end this lecture. You have exactly 10 seconds to tell me if you have any doubt. Yes, Deepak, it is retardation. You have exactly 10 seconds to tell me if there is any doubt. And okay, Sivani, what is your request? Yeah, negative acceleration is called as retardation. Sivani, what is your request? Tell me. Whatever doubt you have, okay. Yeah. Usha, you're welcome. Yes, Rabin, thank you so much. Sivani, what doubt do you have? Just put it in the chat box. I'll wait for you for 10 seconds. Come on. By the time, guys, if others have any doubt, please put it in the chat box. Okay, I'm waiting for the doubt, Sivani. Sivani, you have okay. Forces and laws of motion. Yes, Deepak, I know that. Deepak, don't worry. I am talking to my team. But then we decided that if we are doing forces and laws of motion, your basics have to be clear. That's why we are taking these lectures. We are clubbing important concepts together and trying to take lectures so that this quickly gets over and we can come to forces and laws of motion and electricity and gravitation. Sivani, I didn't get your question, Sivani. If you don't ask me the question, then I have to end the live session because I don't think so anyone else has any question. Sivani, please ask the question. We are waiting for you, Sivani. Acha, what is velocity? Okay, I can explain you what is velocity. Velocity is just like speed. But just remember that velocity, okay, let me just see. Velocity is just like speed. Just one thing, it is in a particular direction. So if let's say if there's a body going in a straight line, so whatever displacement it's covering, you divide it by time, you'll get velocity. If the body is covering more distance in less time, then its velocity is very high. But if the body is covering less distance, okay, if the body is covering less distance in a lot of time, then its velocity is very less. So that's velocity. But there's one twist. Velocity also depends on direction. What does this mean? Velocity depends on direction. If you're taking a body, okay, if it's moving in a straight line, it's moving in a straight line, and let's say the body takes a turn. The moment the body is taking a turn, remember its direction is changing. And because its direction is changing, its velocity is also changing because velocity depends on direction. So if the direction of the body changes, the velocity changes. That's the reason the definition of velocity is displacement per unit time. What do you mean by displacement per unit time? It is what's the displacement covered, what's the shortest distance divided by time. Yes, Satish, I was explaining what is velocity. I hope, Shivani, you got what is velocity. Velocity is displacement per unit time. Okay, Usha, you didn't understand the part of displace. Yes, velocity changes when you're changing direction. Remember, velocity changes for two things. First, if speed is changing, and second, if direction is changing. If speed and direction both are changing, even then velocity is changing. So that's the concept. Okay, Usha, you didn't understand displacement. Remember, displacement is the shortest path. So if there's like a lake or something, yes, if there's a lake or something, thank you, Deepak. You're welcome, Deepak. It means a lot. Now, last concept that I will explain for the day, that is what is displacement. For displacement, if there is a body, okay, if there is a body and there is this body is moving in a like in any direction, okay, and here the body is. Now, if someone tells you what is the distance, it is if you are walking in this road. Okay, if you're walking in this road and someone tells you, Usha, what's the distance covered by you? So distance is this length of the actual path covered by the body. But displacement, you didn't understand displacement. Displacement is the shortest path between initial and final point. It is the shortest path. I will not measure all of these things. I will just take a scale and measure this distance. This particular distance, this is called as displacement. This is called as displacement. That's it. Okay. Fine then, guys. Bye. Have a nice day. Okay. Have a nice day. Yeah, you're welcome. You're welcome, Usha. You're welcome, Sivani. You're welcome, Deepak. It was so fun. And be ready for the next live sessions also. We will send you a link whenever we're having a live session. And don't forget to go through it. And yeah, forces and laws of motion, Deepak, I know about it. I'm going to talk to my team. And once the motion chapter is done, we are going to do that topic. Okay? Bye, everyone. Bye, everyone. Take care.